and I'm originally from the southwest of England, down near Plymouth. Been licensed since I was 14. That was in 1994, I think. So you can do the math. But yeah, so reasonably active in the hobby. Sort of key interests are contesting, particularly on HF. Do a lot of de-expeditions, so traveling around all sorts of weird and wonderful places to operate from, again, mainly on HF. So recent trips have included Svalbard, Montserrat, and the UK sovereign base area on Cyprus, ZC4. So fair bit of travel. Yeah, and also summits on the air is the other activity I do a lot of. So climbing up hills and taking portable equipment. And the thing you'll pick out from all of that is I'm basically an HF operator primarily. Bit of VHF from time to time. We were talking about 6 meters a moment ago, but yeah, primarily HF. So QO100 was something completely new to me. What else should I tell you about myself? Professionally, I work in software. I'm based at the Royal Society of Chemistry here in Cambridge, which is basically an academic publishing and a scientific membership body for chemists. So yeah, that's kind of all about me. So this is going to be a slightly unusual talk, discussing it with Dave earlier, when we were putting the plans together for this. Problem with QO100 is it involves big dishes and big bits of equipment and boxes of equipment. So the easiest way to do it, I have already put together a video on YouTube. So I'll take you through that. That kind of explains the whole process that I've been through and put it all together. And then, as Dave said, we'll go to a Q&A at the end if you have any questions. I should caveat all this with the fact I am absolutely not an absolute expert on the QO100. This is very much the beginner's tale, how I got going. Largely, I think talking to George about this when we started, largely following George Smart M1 Geo's guides, which I believe you've been following as well in your club. So yeah, getting started, how an HF operator sort of approaches QO100. And again, this isn't the only way of doing it. In fact, this is a way of doing it. That's all. And I took the approach of starting with something very simple and basically building the equipment out. I didn't want to start off by investing a whole load of money in a whole load of equipment and then allow it not, and then have it not working or something. So a lot easier to start small. The transmitter receiver I'm going to show in a moment is the Lime Mini SDR, which I already had anyway for other sort of SDR based projects. So that's kind of where I started from. So with that, I shall switch to the video. This is kind of like half an hour. And then, as I say, we'll go to some questions at the end, if that's okay. So I'm going to do a screen share and take you onto that one, and that one. Good. Hopefully this will work. Shout if it doesn't. There should be some noise in a moment. Hello everyone, I'm Dom, M0BLF, and some of you have been asking me about the equipment that I've been using to experiment with the QO100 satellite recently. So I thought I'd put together a little video to explain what I've been doing. But before we get stuck into the equipment, let's go inside and have a little look at some of the theory behind the satellite. QO100 is an amateur radio satellite launched at the end of 2018 and which has been operational since February 2019. Now, of course, radio amateurs have been building, launching and communicating via satellites for decades. So what's novel about this one? Well, it's in a geosynchronous orbit. All previous amateur radio satellites have been in low Earth orbits, which means they rise and set and you have to track them across the sky. Often they'd only be above the horizon for perhaps 10 minutes or less. QO100, on the other hand, is geostationary. meaning that it appears to be in the same point in the sky all the time because it follows the Earth's rotation. Geosynchronous orbits are really expensive. Slots are limited because there's only a small belt where you can put the satellites, and consequently there's high competition for them. All the broadcast and other commercial communication satellites all want to be in a geosynchronous orbit because, well, you wouldn't want to have a motorized satellite dish on the side of your house, and even then to only get TV pictures for a few minutes every couple of hours, would you? So how has QO100 got one of these precious positions? Well, QO100 is actually a couple of amateur transponders that are carried on a commercial broadcast TV satellite known as SHAL-2. It's a satellite that carries a lot of TV programs to the Middle East, operated by the state of Qatar, and it's Qatar that's allowed amateurs to add a couple of extra transponders to the satellite, and indeed the QO in the name QO100 stands for Qatari Oscar. You'll remember that all amateur radio satellites are called Oscar, orbiting satellite carrying amateur radio. One of the results of being in a geosynchronous orbit is that the satellite is extremely high above the Earth's surface, giving a massive coverage range, extending from the tip of Brazil, covering the whole of Africa, Europe and the Middle East, the Indian subcontinent, and even as far as the west of Thailand. There's even a QO100 station near the coast of Antarctica. Now, all of that coverage is accessible from a relatively simple setup and without the vagaries of HF propagation. By the way, if you're watching this from North America, sorry, you don't get to play with QO100. It's below your horizon. SHAL-2 and the QO100 transponders are located at a position known as 26 degrees east, which is to say if you were standing at the North Pole, standing on the Greenwich Meridian, the satellite would appear to be 26 degrees east of south. 180 minus 26 is 154, so the satellite would appear to be at an azimuth of 154 degrees from the North Pole. Here in the south of England, near the Greenwich Meridian, it's at an azimuth of about 147 degrees. Now, as I've said a couple of times already, there are actually two amateur transponders carried on QO100. One of them is the narrowband transponder for voice and for narrowband digital communications, and the other is the wideband transponder for digital amateur TV signals. The principle of operation is the same for both, but as you'd expect, you need rather more power to use the wideband transponder, which I don't have, so I won't be covering it today. For both the narrow and the wideband transponders, they act similarly to crossband repeaters. The uplink, what you transmit onto the satellite, is around 13 centimeters, so around 2.4 gigahertz. The downlink, what the satellite transmits back on, is on 3 centimeters, so around 10.6 gigahertz. Now those bands sound scary to an HF operator like myself, but the useful thing is that the 2.4 gigahertz frequency is similar to Wi-Fi and Bluetooth, so there's loads of common equipment that can be repurposed. And similarly, 10.6 gigahertz is near enough the 11 gigahertz downlink frequency of broadcast satellite TV, so we can repurpose equipment there too. In fact, the main piece of gear you'll need is the 13 centimeter transmitter, but that can be easily and fairly cheaply sorted using an SDR or software defined radio. Make sure you get one that's capable of transmit at 2.4 gigahertz, as some only go up to 1.5 gigahertz, and I'll be showing you how I'm using the Lime Mini SDR in just a moment. Unlike amateur repeaters that have a single input and output frequency, the QO100 repeater repeats a whole chunk of spectrum, 500 kHz on the narrowband transponder and a whole 8 MHz on the wideband transponder, which means many QSOs can happen at the same time. On the narrowband transponder, the band plan resembles that of an HF band plan, with CW at the bottom, then data modes, then SSB, and then there's this mix mode and special purpose section at the top of the band. Please note that no transmission should exceed the 2.7 kHz bandwidth of a standard SSB signal, so you shouldn't be using AM or FM on the satellite. The low and the high ends of the transponder are marked with a beacon, and you obviously shouldn't transmit outside the frequencies contained between these two beacons. The higher beacon may change mode in the future. It's actually an experimental beacon. The low one is CW. In the middle of the SSB band, there's another middle beacon, which is the PSK beacon. All three beacons have a 5 kHz guard bands either side of them, so you shouldn't transmit immediately around the beacon frequencies. The PSK beacon is a useful constant carrier source which we'll use a little later on to stabilise our receive frequency. The PSK beacon also carries telemetry data about the satellite in the same format as that used by the AO40 satellite, so you can use the AO40 receive program to decode it. And it's advised you do periodically decode the telemetry data because the mailbox may contain important announcements about changes to the band plan or other restrictions in force. You decode the band plan literally by feeding the audio of the PSK beacon to AO40 receive. The only other thing you really need to know about operating on QO100 is that you need to be able to listen to the downlink while transmitting. Fortunately, that's easy with a setup like mine. 13 SEMs and 3 SEMs are far enough apart that you don't need any special filtering. Although hearing yourself with a fractional delay can be a little off-putting at first, the main reason is to ensure you aren't transmitting too much power. Your signal shouldn't ever be stronger than the 3 beacons. If it is too strong to the satellite, a siren sound will be injected on top of your transmission, so if you hear yourself coming back with a siren on top, you need to stop and turn down the power. Luckily my setup isn't anywhere near strong enough to trigger that siren, but I have heard it on other people's signals a few times. Remember, we're effectively guests on this commercial satellite, and if we don't play nicely, we may not get a similar opportunity in the future. Okay, well that's the theory. How do you actually get going on the QO100 satellite? Well, obviously we've got the dish here, but a lot of the magic is actually in this box here. So let's open that up and I'll talk you through what I'm using. Okay, so let's talk first of all about how receive works. Receive is probably the simplest thing to get started with. You don't even need one of these big 90cm dishes. 45cm mesh dish is absolutely fine for receiving here in the south of England. So the first thing is you need one of these, which is a standard domestic television LNB. The purpose of an LNB is normally to take the satellite's signal. Domestic satellite television tends to be at about 11 gigahertz, and what we want to do is to take that down to about 900 megahertz for domestic television, which is going to be a lot easier to send down coaxial cable. Your losses are not going to be anywhere near as high. Fortunately, the downlink from QO100 to about 10.6 gigahertz is within the range of most of these LNBs, more or less, and we can then just get the signal down to about 730 megahertz. Now, I should say that everything I'm showing you here is just one way of doing it. It's absolutely possible, for example, to modify the LNB and get it down to the 70 centimeter amateur radio band instead. But I'm using a Line Mini SDR, which means I've got frequency agility. I can very easily just tune into the 730 megahertz where the LNB is coming out. What I would say is if you're getting one of these, make sure you get a PLL LNB. There are a couple of types out there. For domestic television, it doesn't really matter how frequency stable the LNB is. The transponders are very, very wideband, very, very strong, and so frequency stability is not a major issue. When you're tuning into an SSB signal or a CW signal, PSK signal, your frequency stability is much more important. So a PLL LNB is definitely what you want. So normally your LNB would be mounted about here at the focal point of the dish. You'll notice that mine is actually back here. We'll come back to the reason why, but effectively that is just a standard domestic television LNB, and the coax that comes out of it is bringing me the QO100 signals at about 730 megahertz, as I say. So inside my magic box of tricks, let's follow what happens to that signal. It's coming in on the coax here, and the first thing it hits is going to be this thing here. This is a bias T, and all that's doing is that's supplying the 12 volt supply up to the LNB. The LNB is an active component and needs 12 volts. The RF is just passed straight through the bias T, so that's now going to go into the input into the Line Mini SDR. You'll notice I've added some heat sinking onto this Line Mini, and there's also a fan back here as well, and that's because the Line Mini can get very, very hot if it's working particularly on transmit. The receive signal is then just sent down the USB cable. Where's that gone? It's down here, down the USB cable to the software for decoding. Now this is a USB 3 cable, gives much higher bandwidth than USB 2, it's what the Line Mini SDR uses, but you do need to be aware that the maximum length of cable that's specified in USB 3 is 3 meters, so that's going to limit where you can put your laptop relative to your dish. Although obviously there are ways around that in terms of sending USB over things like IP. That's kind of out of scope for the moment. So that's all there is on the receive side. Let's take a look at the transmit side. And again, the basis of it is again the Line Mini SDR. That's going to be doing our transmission. Coming out of the TX port here into this piece of cable along here. And that then goes into these two, one there and one there, little driver boards. These are SPF 5189Z chips, very, very cheap on eBay. And they're specified in theory up to 4 gigahertz. So these are just going to take the 10 milliwatts or so that comes out of the Line Mini SDR and just bump that up to about 150 milliwatts, which is enough to drive our main amplifier. So these are require 5 volts. The rest of this circuitry basically is a 12 volt circuit. So we've got a voltage regulator, where's it gone, back here, with a big heatsink on it, which is going to supply the 5 volts to those two driver boards. Now, one thing I got wrong when I first started playing with this kit is I started off by using an automotive step-down transformer from 12 volts to 5 volts. Yeah, not recommended. They're not quite good enough for this purpose, and my signal ended up with all sorts of sidebands and nasty effects on it, and looking at it in an oscilloscope was quite scary. So definitely want to use a decent voltage regulator for 5 volts. And thanks to M0WUT for pointing that out to me. So anyway, the signal, once it's come out of the last of these step down of these driver boards, goes into this piece of coax, which then on the lid of the device, just for cooling reasons, goes into the side of this. Now this is marketed on eBay as an 8-watt Wi-Fi amplifier. Now, two things with that. First of all, it's not 8 watts. We've had it open. The bits inside it, maximum it can possibly do is 2 watts. And you wouldn't want to use this on Wi-Fi either. It's not going to be type approved, and particularly in Europe, it's not advisable to use that on Wi-Fi. The other thing to know about these is, although they're very cheap, because they're designed for Wi-Fi, they have they're designed for a very fast transmit-receive changeover cycle, which isn't really suitable for use with SSB and CW. So easiest thing to do is that there's a very simple mod you can do, details in the description below, where you just put a small solder bridge between 2 pins on one of the chips, and that will lock it permanently into transmit, which is absolutely fine. You know, SSB and CW, there's not going to be a signal there if we're not transmitting, so we can lock the amp permanently in transmit. Signal then comes out of the amp on this piece of coax. This is going to be your main piece of coax going to your dish. So you want to make it as short a run as possible. We're at 13 sems here, and we've only got 2 watts. We don't want to be losing very much power, so keep it short and decent quality coax. Well, this stuff is CRF 200, which is a Chinese clone of the LRF 200, and fairly decent stuff. It's still, though, the 1.25 meters I've got here has a loss of about 0.55 decibels per meter, so I'm still going to be losing probably about half a watt or so of power by the time it gets into the antenna. So talking of the antenna, let's take a quick close-up of this antenna. It's a potty antenna, as it's known. It's a patch of the year antenna, and let's take a quick closer look at how that works. Okay, so here's the potty antenna, and I certainly don't claim to be an expert by any means on these microwave antennas, but so this is my understanding, is that this piece here is the driven element. The piece behind it, So this piece here is the reflector, and the not quite circular cutout of the metal is what gives us the circular polarization that's needed for the satellite. This piece, by the way, is just a lens to help focus for the waveguide going back to the receiving LNB. By the way, the red bits here, and also there's a red holder that's just holding the waveguide into the LNB holder. These are 3D printed. They're designs out on the internet thanks to Rob M0VFC, who put together the 3D prints for me. Now, one thing I should say just from a safety perspective is that I wouldn't want to be standing right here when I was transmitting. Now this, as I say, is a 90 centimeter dish, and the 2 watts that's produced at the patch antenna, by the time it hits this dish, which has got a gain of about 26 dBi, we're going to be looking at about 500 or so watts of ERP that's going up into the sky. So fortunately it's got a fairly high angle of takeoff, which means that by the time you get to the other side of the road, it's going to be way above the tops of houses, but I wouldn't want to be standing right here, as I say. The other thing I should mention is that by the time you're getting up to dishes of this sort of diameter, the larger the dish, the slightly more difficult it is to get it exactly bang on where the satellite is. It is just a pinpoint in the sky. So if you've got a 45 centimeter dish, it's going to be quite easy to find that signal. It's not quite so directional. At these big diameters, certainly if you're getting up to the sort of 1.2 meter diameter dishes, which you're going to need to do if you're going to get onto that wideband transponder, then you're going to be needing to have very, very precise alignment of your dish. Now, one very annoying thing to just be aware of with these Wi-Fi amplifiers is that, like most Wi-Fi equipment, they, on one side, use reverse polarity SMA. So this is the normal RF input to it, and that is a normal SMA socket. So that's an SMA female. It's got the socket, it's got the thread on the outside ring, whereas on the other side, the RF outside is a SMA, a reverse polarity SMA, or RP SMA. This is actually the female RP SMA. It's got the plug in the middle, unlike what you'd normally find with a female. So this is an RP, a reverse polarity, but it has that screw thread on the outside as well in the female. Really important to be aware of this. It completely threw me at one point when I tried to connect together a patch lead, one for a female SMA into a male SMA, RP SMA, and the result was that there was actually no central connector at all. Okay, so I've now come back inside and we're ready to start setting up the Lime Mini SDR with SDR console. So to do that, first thing I'm going to do is to click on Definitions and then search for my Lime SDR. It has been found, that's good, so we'll add it to the list. Now, I could just leave it like that, but if I do that, I'll have to keep track of 3 frequencies at all times. There'll be the 3 centimeter downlink frequency, there'll be the frequency I need to tune into, which will be after the LNB has down converted it to about 730 megahertz. And then there's also my 13 centimeters uplink frequency. That's quite a lot of frequencies to keep track of at all times. So it's a lot easier if SDR console can just show you the 3 centimeters downlink frequency, and that's the only one you need to worry about. And we can do that using this converter selection option. So we'll turn that on. And you see I've already set this up here. Now the TX side, we're going to need an RX and TX one. The TX side is the easy one. 8.089.5 is the TX frequency. That is that's the offset between the 13 centimeter uplink frequency and what it then comes back down on 3 centimeters. The RX converter is the offset, which is your local oscillator frequency of your LNB. This can be a little bit variable. It tends to be 9.750.2 or 9.750.0. As you see, mine here is 9.749.9. As I say, it is variable, The only way you can actually find this out is trial and error. So what you'll need to do is, when we come on in a moment to synchronizing to the geostation, to the PSK beacon, if you don't see the PSK beacon come up in the bottom half of the screen when we do that, that will suggest that your local oscillator frequency here is wrong. You'll need to come back and change it. So let's save that for now, and we'll save that. We'll select the Lime SDR Mini, and we need to select a bandwidth which is capable of transmit, because we want to be transmitting. The Lime Mini SDR only does 750 kilohertz bandwidth on transmit, so we'll go with that. So let's click start, and hopefully the rig should be found and SDR console will start receiving signals. As I say, I'm not actually plugged into anything here. I'm inside, so we don't actually expect to receive anything. A couple of other things we need to do to get SDR console ready to receive on SHAIL. And the first of those is that by default it can only display frequencies up to 9.999 gigahertz, and of course we've got a 10.6 gigahertz downlink frequency that we're interested in. So we need to add an extra digit. That's very easy to do. You just go to View and Options, and then on the Spectrum tab, just allow a frequency range up to 99.9 gigahertz. That will add an extra digit on the next restart. Next thing to do is, we currently don't have a transmit panel, so we wouldn't be able to access any of the transmit features. We do that just by going to Transmit and then to DSP, and that's brought up our transmit panel. So just to show you around here, we've got on the left hand side, we've got our receive frequency, we've got the sound card that's being used to receive signals, and we can also set the modes and the filters that we are interested in. On the transmit side, we've got the transmit frequency. We can optionally choose to synchronize that with our receive frequency. You've got transmit mode, and again you can synchronize that so it's the same as your receive mode. Then you've got the TX button, which is what we'll be actually using to transmit with, and your drive. You'll want to turn the drive up, obviously, to get any RF out. Down here is where we'll select the microphone we're going to be transmitting with. So that's got us our transmit panel. The last thing to do is we'll need to synchronize our LNB with the geostationary beacon on the satellite. And to do that, we go to the View tab and to the Select More Options icon, and we're going to need to turn on the geostationary beacon. Now when I click OK, it'll want to restart the software so that it can add that extra icon to my toolbar to allow me to do that geostationary beacon synchronization. So let's click OK and restart. So the program's now restarted. I've got my geostationary beacon icon here, and I've got the additional digit for the gigahertz that's available to me. So it looks like we're all ready to go. Let's go outside and wire it all up. We'll need to connect in, of course, the laptop, a USB headset, and of course we need to put the top on the box of equipment as well. So now we're going to need to correct any drift in the LNB, and the way we're going to do that is by locking SDR console to the PSK downlink beacon, that beacon in the middle of the SSB spectrum. So I'm going to click on this on the View tab on the geostationary beacon, and what you get here is another little block opening up at the bottom of your screen, which includes, hopefully you'll be able to see fairly obviously, the PSK beacon. It's here at about 7489800 for me. We now press the play icon over here. That will now lock everything, and you'll see that on the top half of my display all the frequencies have shifted. This now means that my frequencies are corrected for the drift of the LNB, and as long as nothing drifts too far, that will now stay locked. So that's about it. Let's give it a go.
Mike 0, Bravo Lima Foxtrot. This is Delta Lima 2, Quebec Bravo, deal 2QB.
Okay, Delta Lima 2, Quebec Bravo. Delta Lima 2, Quebec Bravo from Mike 0, Bravo Lima Foxtrot. Thank you for the route. Nice signal to satellite to about 5 and 8. 5 and 8. Name is Dom at Delta Oscar Mike. Delta Oscar Mike. And the situation near the city of Cambridge. Cambridge in Juliet Oscar 02 Bravo Golf. Juliet Oscar 02 Bravo Golf. It's about to from Mike 0 Bravo Lima Foxtrot.
Good morning, Mike 0 Bravo Lima Foxtrot. Delta Lima 2 Quebec Bravo. I must apologize, I was not on your frequency when I called you first. Because I was not finished with setting up the VSO of my 2-meter transmitter. I was missing 200 hertz. I had the kilohertz fixed, but the decimals not. Okay, Dom. Thank you very much for the call. My name is Klaus. Kilowatt Lima Alpha Uniform Sierra, and QTH is Cologne. Charlie Oscar Lima Oscar Golf November Echo, and locator here is Juliet Oscar 30 Mike X-Ray. Juliet Oscar 30 Mike X-Ray. Been writing to Erica's doing some things, looking for a pen. Heard you calling, and then it had to everything had to go real quickly before you were gone. Okay, anyway, Tom, thank you. Mike 0 Bravo Lima Fox Delta Lima 2 Quebec Bravo.
And so that's QO100 in a nutshell. If all of this sounds interesting but a bit too much investment right now, a great place to start is the British Amateur Television Club's Web SDR. That allows you to listen to the satellite via the web without spending anything. You simply connect to a receiver at the famous Goonhilly Earth Station in Cornwall in southwest England. There's a link in the description below. And finally, of course, a massive thanks to a whole load of people at AMSAT, particularly AMSAT Germany and the state of Qatar, who've all made QO100 happen. I've been really enjoying the satellite, and I hope you do too. I'm Dom, M0BLF. Thanks for watching. Okay, so that was the video. Hope you all have heard that okay. So yeah, as I said there, that's just one way of doing it, using that setup with the Lime Mini SDR to do all the grunt work. You can obviously also use up converters and down converters. You can modify the LNB to bring the signal down to the 70 centimeter band. You can GPS lock the LNB so you don't have to do the frequency correction based on the beacon. So there's a whole myriad of different approaches you can take. This was purely the one that I found easiest to get started with based on where I was starting from. So yeah, that's I think pretty much all there is to say on that. But yeah, happy to take any questions.
Okay, Dom, one of the questions I sort of had when you were going through the setup and everything else there, do you think this kit could be made portable? You know, is it possible for a field day using QO100? How would you even do that? Is there portable kit around that can be used for it?
And the sort of equipment that I've got there is pretty portable actually. The dish on the tripod is, you know, as long as you can carry the 95 centimeter or 80 centimeter dish, 90 centimeter dish, that's your limiting factor, right? Because the rest of it is actually really very portable. It's that one box, and you need to get a 12-volt supply into it, which, you know, a field day generator should be perfectly adequate. And then a laptop.
Yeah. If anyone has any other questions, you can wave your hand or raise your hand using the Zoom function, or unmute yourselves there and feel free. How much, actually, how much are you generally talking? Maybe even, Dom, for that
Oh, so how are we talking? So the Lime Mini is probably the most expensive single component. I think they are currently going at about £250, something in that sort of region. Then what else have we got? Dish was about £30. The potty antenna is about £40. The LNB, you're talking about £5. It's a domestic part. I've £20 for the length of coax that I had, because it's decent coax, and with particularly with the RPSMA on the end of it. Then the other bits inside that box are you're talking sort of a few pounds for each individual bit, so it really is very, very cheap compared to a decent HF rig, for example. It's very easy to get going, and as I say, the Lime Mini SDR, that single most expensive bit, SDRs by their nature, you have so many different uses for them. You're not locking up a single thing to only do QO100. You can go and use this same device for multiple other projects as well.
And for that cost, you have instant access to the west of America to the east. Was it eastern Russia as far as that, and down to
not America, but you can get into the tip of Brazil. That's as far west as it goes.
Yeah, Brazil, and across
and then across to India and coast of Thailand, which is, and you're not subject to the propagation on HF. This is something that I've really struggled to get my head around, is the fact that it's actually almost too easy. It just works.
Yeah.
If it works at all. You mentioned the drivers, Dominic.
Yeah.
SPF something, but I didn't get the pencil working.
Yeah, it's the one George has on his website, which sorry, let me look that up quickly. I think it's SPF 5190, if I remember rightly, but I will double
I have one
check
here.
that. Aha, do you? Let's bring that one up.
Yeah.
5189Z, SPF 5189Z, and those are literally £3 or £4.
Thank you.
Yeah. Don't know if that's focusing in on it.
That's the one. Yep. There you go,
That's
George.
the one there.
Yeah. It comes pre-mounted on the board with the SMAs at either side of it, and you literally just plug it in and give it 5 volts.
Yep. That's it.
We actually, so when I was setting this up, I mentioned in that video that I set this up partly with M0WT, who, because of his job, has access to serious microwave test equipment. We did try having 3 of those driver boards in series and putting that into the Wi-Fi amp, and that was horrific. You were right, starting to overdrive the amplifier, bit too much input on there. Sideband suddenly came up, all sorts of noise. So actually, just slightly underdriving the amp by only putting the 2 boards in was much more effective. I probably wouldn't have noticed that without the test gear, but yeah.
Yeah, I think George says the same thing on his website.
Yeah.
And I've seen recommended putting in a 2.4 gig bandpass filter in between 2 of them.
Yes, I probably should. On the other hand, nobody's mentioned any issues. So
Well, that's good.
There have been people actually say to me that they are surprised that my signal from the Lime is quite as good as it is, because there's lots of dodgy signals from that Lime on the satellite, and it sounds like maybe people are making that mistake I referred to in that video, where I used a very cheap step-down transformer from 12 to 5 volts to power those driver chips, and yeah, if that voltage isn't clean, then the signal just ends up horrible.
Jack, GI4LVC.
Hi, Jack.
Could I ask you about the transmit antennas, which looked in the video like 2 metal discs?
Yep.
Is that a purchased item, or is that something you manufacture?
It can be either. So this was designed by a combination of a guy in England and somebody in the Netherlands. They published the design. It's an open design. If you've got access to the metalworking facilities, you can just download the measurements and do it yourself. However, the guy in Holland has now actually gone into business, or partly manufacturing these himself, and those are sold through various online retailers. I actually got mine from a radio shop in France. I don't think there's a UK distributor at the moment, but so I imported mine from France, and it was, I think, 45 euros, something like that. So really pretty good value. It saves an awful. There's one thing you have to solder. That's about it. So yeah.
Yeah, Dom, it's Passion Radio in Paris.
That's the one, yeah.
And I did the same as you. I bought one, and then I used it as a template to build this one.
Yeah.
So this one's a bit rough and ready compared to the bought one, but it's 22 mil copper pipe, and it's 1 mil brass sheet. I fitted a BNC on it, and soldering was the hard bit. Too much heat in the brass bends. But yeah, an afternoon makes one up.
Yeah, it's a really nice, really simple design, and there's lots and lots of people using these. They seem to work really well. And you've obviously got the waveguide there, which means you can put the LNB at the end of it, and then you're not, because the other way of doing it is to have two dishes, one for transmit, one for receive. That obviously starts to use up garden space. So having that waveguide and being able to put the LNB at the end of it just keeps everything that bit more compact.
How much hassle to get the lengths, the distances right on the LNB going forward towards the dish?
There is. I had no particular hassle with that. The only thing I've noticed is that it depends on your dish design a bit, whether or not, because that patch of the ear antenna, the reflector, if you like, is obviously quite a large diameter. And I found there are some dish designs where it's very difficult to fit that at the focal point of the dish, just because it's much larger than the standard LNB would be. If you look at the video, my dish has actually got a bent arm for that LNB holding, which is a slightly unusual design. But I got that dish specifically because it does have that ability to hold that extra diameter without, because otherwise you're going to have your patch of the ear antenna not quite at the focal point, which is obviously going to lose a bit of gain by doing that. So, but you make do with what you can. It doesn't. The LNB just sits on the end of the waveguide. There's no real measurement there at all. It just sits on.
And you mentioned that plastic lens.
Yes.
How critical is that? And is that something that you get off the top of a toothpaste tube?
So that lens actually comes as part of the kit from Passion Radio. There are two designs. There's an original design and there's that one. Apparently the new, that's right, there you go, George is holding it up for us. The new design apparently is better with the offset dishes. The old design, which is slightly more pointy, is better with an other types dish. It's literally just a piece of plastic, and it just fits in at the top of the waveguide. But as I say, it does come as part of the kit if you buy the bought one. Thanks very much, George. Fantastic assistant.
I know on George's website, he talks about he's using the cheap Chinese preamplifier, but he also talks about the analog devices unit. Have you tried that, or?
I haven't yet. That's probably the next thing. As I say, I wanted to get started with as little investment as possible, just because I didn't know how it was going to work out, whether I'd enjoy it or not. So I was trying to keep it fairly cheap to start with. Now that I do know it works, well, I think probably looking at a decent amplifier is the next thing on the list. But yeah, that's then also at that point that starts to open up the world of the wideband transponder and TV at that point. So once you've got a bit more power behind you.
And would you recommend everyone giving this a go then, Dom?
Look, amateur radio is a broad church, right? There's all sorts of things you can do in the hobby. It's just one more facet. So if you think you might be interested in it, go for it. But it's not going to be to everyone's taste. As I say, in some senses, it's a bit too easy. Also, but for me, it was largely the challenge of moving from HF into this whole world of microwaves and dishes and things I'd never had to deal with before. So it was really interesting, and well worth doing, I think.
The box, Dom, that you used, did you use a metal box or just a plastic box? Or
just plastic project
plastic?
box. Yeah. Possibly, arguably, it should be more screened than that. The thing I've had to do is really watch heating on it. As I say, need to keep the coax length from that box up to the LNB, up to the potty, as short as possible. So I've been running this outside, a black plastic box on a sunny day with lots of heat generation components in it. I had awful problems with to start. That's why the heat sinks in there. That's why the fans in there, because the Line Mini SDR just really does not like it at all. I actually had it completely shut down on me at one point just because it overheated. So yeah, just need to watch heat.
So air circulation and temperature and everything else is definitely something to look out for if anyone's setting up any of these.
I would say so, particularly if you're going to have things outside. If you just go mount it all in the box and don't think about air, it will not survive very long, as I found.
Maybe a Baco foil jacket would be good.
Possibly, yeah. As I say, I've responded by just drilling lots and lots of holes into the box and sticking your fan in. Although that does undo the weatherproofing, which is what I'd originally hoped to get from it. I'd hoped to be able to leave it outside, which I now can't do. But yeah, so the next kind of thing I want to do there is investigate USB over Ethernet, or over Cat5 cable at least. Because obviously I've now limited myself. Right? I've got a meter and a bit of coax from the box to the potty. I'm limited by a 3-meter USB cable to the laptop. That means my laptop's now got to be within 4 meters of the dish. That's all I've got. So by moving the USB into a USB over Cat5, although that starts to get expensive at that point, but at least I could then actually operate the laptop remotely.
And from the comfort of your own shack.
Rather than having to be outside, yes.
Anyone else have any other questions? Now's your chance.
No. Cool. Well, my email address and everything is on qrz.com. If anyone does think of anything afterwards, very happy to take that up separately.
In the club, as we were saying before we got started, Dom, we had been working on a receive side station for quite a while. We've had that up since sort of probably spring last year. Very simply set up. Well, one of the club members donated us a dish, but it must be 1.2 meters. It's absolutely massive.
Fantastic.
Which getting it pointing directly at the satellite was great fun. Once we got it, we were getting great signals, but we had lots of problems initially. And I'm just thinking about the issues you had initially with the power supply on transmit, and we might have had some of those on receive with the power supply we were using to drive the LNB. It wasn't a particularly high quality regulated power supply. It was a wee brick power supply. It could have been something in there. We would get very strange modulation on receive.
Okay.
Go
on.
No, I was going to say once we got the synchronization with the beacon going, things improved, but there was still, it was almost an auroral effect on receive, which I don't think, yeah, Andrew's there. I don't think we ever got to the bottom of it fully.
Okay, interesting. Don't have any ideas myself. I will ask around and see if anyone's got any ideas of that. I've not heard of an auroral effect. I would be very surprised, mind you, if a slightly non-linear power supply actually caused that much trouble for the LNB. These LNBs are able to basically take anything. You know, they will. When they're in use for satellite TV reception, they switch polarity based on the voltage input into them, and they will quite happily get take anything from about 11 up to 20 odd volts, because somewhere around the 14-15 volt point is where it switches from a vertical to horizontal polarization.
Okay.
So they will basically take anything.
Now you mentioned that, what is the polarization that's needed for uplink and down?
It's all circular,
Okay.
which is why the potty
Yeah.
has got the cutouts on it.
It certainly develops quite a bit of ERP once you get it onto that dish.
Yeah, it will do. Yeah. There are a lot of people who have used the television channels on the satellite for the commercial TV channels, BBC Arabic and the like, to help with aligning the dish. Just because if you get a satellite TV receiver onto the end of it, the signal metering and things in that can be quite helpful for helping get the dish in the right point. To be honest, I did, because I had it available, I used a 45 centimeter mesh dish as the initial alignment, because I say that's very forgiving. You can basically put it just in the right point. And once I'd established roughly where the satellite was from that, then I swapped over to the 90 centimeter dish and did it that way.
Dom, you have your obviously finger on the pulse with regards to this QO100 and AMSAT stuff and everything else. Do you know, is there any other plans for add-ons, piggyback rides on the other commercial satellites you're going to go up to around the other parts of the globe, or?
I haven't heard of anything. I don't really have my finger on the pulse that much, so I'm definitely not in the inner circle of AMSAT, so I probably wouldn't have heard of anything. That said, only 2 months ago the transponder on QO100 was increased. It was basically doubled in size. The bottom beacon up to what's now the mid beacon. That mid beacon was referred to as the upper beacon before, and they hid the other half of the transponder from everyone. They left it inactive until they knew how much use there was going to be. And then on the first anniversary of the satellite back in February, they said, surprise, surprise, that is actually the mid beacon, and here's the top beacon. So yeah, they've only just doubled it in size. So I don't quite know what else they might have up their sleeve.
But very interesting that obviously things have been used so much that it was a case of let's wait and see what happens, and everyone has sort of made great use of it. So long may it continue. In a responsible manner, as you say, people within the right power limits. Because we in the amateur community, obviously, we are piggybacking there for free, and you know, we don't want to ruin that either.
No, and they do have the ability to turn it off, and I'm sure they were just seeing how much malicious use there was to start with before they gave us the whole bandwidth. And fortunately, no, they've done that. So, yeah.
The received from G3BFC, the received signal as you replayed it on the recording, Dom, it was quite noisy. In other words, you wouldn't put that out over Radio 4 for very long, or even Cambridge 105. Is there anything that is actually of entertainment quality? I'm not talking about content, I'm talking about signal to noise.
Signal to noise. Obviously, you know, the narrowband transponder, partly your signal strength is determined by dish size. I could get a bigger dish, that would increase signal size, right? But we are still using USB. and USB is never going to be great quality. If you go onto the wideband transponder, where the digital TV amateur stuff is, there they are using the standard DVB-S2 modulation that standard satellite television uses, and there you are, basically FM quality at that point.
And you've heard that to be FM quality, nominally.
Yeah. I've watched the reception of a digital TV signal, and it is really good quality. I mean, we're still much lower symbol rates than standard satellite television would have, so it's not absolutely broadcast perfect quality. The picture does pixelate a bit, but the audio is absolutely fine.
Thank you.
Okay, any other final questions here? We'll give it about another 10 seconds and then we'll begin to close it up if no one has any other burning desire questions.
Cool.
No?
No.
Okay,
Well,
Tom, from the Mid-Ulster Amateur Radio Club, thank you very much for
no problem.
joining
Lovely
us.
to meet you all, and thanks very much for inviting me.
Yeah, no problem at all. Great to have someone along, especially over Zoom, and everyone else that's joined us there. Thank you very much. More than welcome. As I say, this is a weekly series that the Mid-Ulster are producing, and next week we have John, GI4BWM, on the DMR and how it actually works into the server and everything else and repeaters. So the link will be on our Twitter page and our Facebook feeds and everything else, and you can email me directly as well, dcparkinson@icloud.com. It's on QRZ on the 2i0SJV if you'd like to be included in our weekly email drop with the link and everything else. So, Dom, thank you very much. Much appreciated.
See you all soon.
Yes, all the best.
Cheers.